Through the black silence of space, a shadow begins to rise. At first it is only a faint glow, then a titanic world emerges from the void. Jupiter, not merely a planet but a god of storms, its clouds swirling in endless motion. The great red spot glares like an eternal wound on the face of the sky, a storm older than humanity, roaring soundlessly across a world so vast it could swallow Earth whole. Beyond it waits the spectral blue of Neptune, its winds faster than the speed of sound, whipping clouds into ribbons that vanish almost as soon as they appear. Uranus spins on its side, a pale and ghostly giant with a tilted magnetic field that defies expectation. And then comes Saturn, robed in light, its golden rings stretching across space like the crown of a celestial monarch. These are not quiet worlds. They are cauldrons of violence. Their storms dwarf mountains. Their atmospheres forge rains of diamond. Their magnetic fields sing with radiation strong enough to destroy a spacecraft's instruments. And yet, for all their size and power, they remain veiled in secrecy. What lies beneath their clouds? What secrets churn in their hidden depths? Did they shape the orbit of our fragile Earth, clearing the way for oceans and life to emerge? Or do they still hold the power to erase it all? The gas giants are more than distant planets. They are architects of the solar system, silent guardians watching from afar, and perhaps, when stirred, the most dangerous forces we have ever known. If you are new here, join the journey. Like, subscribe, and let's begin. In the beginning, before the age of glass lenses and observatories, the night sky was a living map of gods and omens. The ancients watched as 5 wandering lights drifted across the firmament, slower and more majestic than the stars. To the Babylonians, Jupiter was Marduk, king of the gods, a celestial sovereign whose motions foretold the fate of kings. Babylonian scribes kept clay tablets inscribed with the planet's path, marking its retrograde loops with the precision of priests tracing divine law. Saturn, slowest of all, was the great ancestor, Kronos to the Greeks, the god who devoured his own children. These planets were not yet understood as worlds. They were signs, messengers, moving lights in an otherwise fixed and eternal sky. For thousands of years, that was all they could be. Lights. Even Aristotle, in his perfect spheres and crystalline heavens, could only imagine them as embedded in celestial shells. The heavens were unchanging, eternal, made of a quintessence separate from the imperfect matter of Earth. But the first crack in this perfect picture came with the Renaissance, when a small primitive telescope was turned toward the sky. In 1610, Galileo Galilei raised his crude instrument, no more than a tube with ground lenses, and pointed it at Jupiter. What he saw shattered the ancient order. Around the bright disk of the planet he saw tiny stars, but they were not stars at all. Night after night, he watched them move, sometimes disappearing behind Jupiter, sometimes reappearing on the other side. They were orbiting the planet. 4 tiny moons, Io, Europa, Ganymede, and Callisto, revolving around a world far beyond Earth. It was the first proof that not everything revolved around us. The cosmos was no longer geocentric. It was an archipelago of centers, each with its own moons, its own realm. Galileo's drawings of these nights were a quiet revolution, one that would eventually dethrone humanity from the center of creation. As telescopes grew larger, Saturn revealed its own marvels. In the mid-1600s, Giovanni Domenico Cassini peered through the improved optics of Paris Observatory and saw that the strange appendages of Saturn were not solid handles, as Galileo once thought, but a system of thin rings. He observed a dark gap between the rings, now known as the Cassini division, and charted Saturn's moons, one after another. This was no mere star-like light. It was a miniature system, a cosmic jewel with companions circling it like a royal procession. Then came a discovery that expanded the solar system itself. In 1781, William Herschel, a musician turned astronomer, was scanning the night sky when he saw a faint object that appeared as a tiny disk through his telescope. It moved slowly against the background stars, not like a comet but like a planet. He had found Uranus, the first new planet discovered since antiquity, the first to be revealed by science rather than mythology. The solar system had grown overnight, but there was more. Astronomers noticed Uranus did not move exactly as Newton's laws predicted. Something massive was tugging at it, distorting its orbit. In 1846, Urbain Le Verrier working with only pen, paper, and mathematics, calculated where this unseen planet must be. Johann Galler turned his telescope toward that precise spot and found Neptune waiting, as though it had been summoned by mathematics alone. This was an unprecedented moment, a planet discovered first in the mind, then in the sky. It was a triumph of reason, a testament to humanity's ability to read the cosmic code. With the discovery of Uranus and Neptune, the solar system was no longer the simple clockwork imagined by the ancients. It was a vast, layered cathedral of worlds, extending into the deep and cold dark. Each new planet was more alien than the last. Jupiter's striped bands hinted at furious storms. Saturn's rings glowed like a cosmic halo. Uranus rolled on its side like a top knocked over by a careless hand. And Neptune, faint and distant, was a sapphire ember at the edge of night. Early natural philosophers and scientists speculated endlessly about what these giants might be. Were they solid spheres, barren like Earth's moon? Or were they made of strange substances unknown to terrestrial chemistry? Some believed Jupiter might be a failed star, a body that had nearly ignited into fusion but fell short of the mass required. Others thought the planets might harbor life under their clouds, a speculation that persisted for centuries. An idea of oceans of gas, floating creatures, even civilizations hidden from the sun. This period was not just one of observation, but of reimagining the place of humanity in the cosmos. The giants were not only astronomical curiosities, they were invitations to think bigger, to understand that our solar system was not a neat arrangement of clockwork gears, but a sprawling, dynamic system filled with colossal storms, invisible gravities, and worlds beyond imagining. The discovery phase was a threshold moment. The curtain had been pulled back, but what lay behind it was only the beginning. Each new observation revealed a greater mystery. The gas giants were immense, powerful, and strange. And even as they were charted, measured, and named, their true nature remained elusive. Beneath their cloud tops, what lay hidden? Did they possess solid ground? Or were they endless depths of gas and liquid, with pressures so great they could crush steel? The more scientists looked, the less these worlds resembled anything on Earth. It was a new age of wonder. The night sky was no longer just a tapestry of points and patterns. It had become a frontier, and the gas giants were its most formidable sentinels. The early astronomers had given the giants names, had traced their paths, had even sketched the bands of Jupiter and the rings of Saturn. But for centuries, they were still seen as distant, alien twins of Earth, perhaps covered in cloud, but surely solid beneath, just as our own planet was solid under its sky. The gas giants were thought to be enlarged versions of home. The truth, when it came, was far more unsettling. The 20th century brought new eyes to the heavens. Telescopes were no longer mere extensions of human sight. They had begun to dissect light itself. Spectroscopy, the art of splitting starlight into its hidden rainbow, became a key that could unlock the chemistry of the planets. When astronomers trained these instruments on Jupiter and Saturn, they found signatures not of rock, but of hydrogen and helium, the very gases that compose the sun. These worlds, it seemed, were not cousins of Earth at all. They were something far stranger, half planet, half star, with no clear boundary between sky and ground. This was a shock to the human imagination. A planet with no surface, no mountain ranges, no seas, no place to stand, seemed almost to defy the definition of what a planet was. If one could somehow descend through the swirling clouds of Jupiter, there would be no solid landing, no final floor, only a deepening abyss of pressure and heat, until matter itself would crush into exotic states unknown on Earth. Saturn, Uranus, and Neptune were no less strange, each offering only an endless descent into darkness. Then came the first emissaries from Earth. The space age brought machines that would cross the gulf and fly past these distant titans. Pioneer 10 and 11 were the first to sail through Jupiter's realm, followed by Voyager 1 and 2. They revealed not placid balls of gas, but worlds alive with turbulence and power. Jupiter's great red spot, seen by telescopes for centuries, was now a maelstrom larger than Earth, its winds raging at hundreds of kilometers per hour, its crimson clouds churning for perhaps 4 centuries without pause. The more the probe saw, the stranger the giants became. Jupiter and Saturn were found to glow faintly in infrared, not merely reflecting sunlight, but shining with their own heat. They were giving off more energy than they received, as though they carried internal furnaces. For Jupiter, the explanation seemed to be leftover heat from its formation, slowly leaking into space. But Saturn's excess heat was harder to explain. It seemed too bright, too warm, as if some hidden process deep inside, perhaps helium raining down through metallic hydrogen, was stirring and heating its interior. And then there were the magnetic fields. Jupiter's magnetic field dwarfs every other in the solar system, a magnetosphere so vast that if it were visible in the night sky, it would appear larger than the moon. Spacecraft detected belts of radiation trapped within it, so intense they could fry electronics and endanger astronauts. Auroras glowed at Jupiter's poles with a power 1,000 times greater than Earth's northern lights, driven not by the solar wind but by the planet's own rotation and its volcanic moon Io, which spews sulfur into space to feed the magnetic storm. Saturn, too, possessed an immense magnetic field, perfectly aligned with its axis of rotation, something no dynamo theory could easily explain. Uranus and Neptune, when Voyager 2 finally reached them, revealed magnetic fields even stranger, tilted wildly off-center as though their dynamos were lopsided or broken. These were not merely planets, they were magnetic giants, cosmic engines generating invisible cages of energy. Each discovery was a rupture with what was expected. Planets were supposed to be solid worlds, warmed by their star, with magnetic fields modest in scale. The giants refused to conform. They were deep, turbulent, radiating heat from within, generating colossal storms and magnetic seas. Beneath their atmospheres, hydrogen itself was being transformed by pressure into metallic states. An ocean of liquid metal hydrogen, conducting electricity, driving dynamos that powered fields of unimaginable scale. The picture that emerged was not one of familiar worlds, but of colossal laboratories of physics. The gas giants were not merely objects to be catalogued. They were natural experiments in the behavior of matter under conditions impossible to recreate fully on Earth. Their storms were not just weather, but the fluid dynamics of planets the size of miniature suns. Their magnetospheres were planetary-scale particle accelerators, shaping the space around them with invisible force. For humanity, these revelations were not just scientific, but philosophical. They forced a re-evaluation of what it means to be a planet. Earth, with its comforting solidity, its temperate climate, its protective magnetic cocoon, was not the default template of a world. It was an exception, a fragile outpost in a solar system dominated by titanic gas spheres with no surfaces, no ground, no fixed boundary between air and core. The shock was not just in the data, but in the imagination. A person standing on Earth could look at the moon and imagine walking there, imagine planting a flag, imagine building a house. But a person looking at Jupiter could imagine only falling forever through clouds of ammonia and hydrogen, into pressures that would crush flesh, steel, even atoms into new forms, until at last one reached a place where hydrogen had turned to metal, and the concept of surface had lost all meaning. The gas giants, once thought to be passive wanderers, revealed themselves as dynamic, restless, and dangerous. They were no longer just points of light to be mapped. They were roaring furnaces, magnetic titans, storm-racked worlds of endless depth. And if these were the rulers of the outer solar system, then Earth's calm orbit, its stable climate, and its very survival must have been shaped by their invisible hands. The discovery of their true nature marked a turning point. The solar system was not an orderly clockwork of familiar worlds. It was a theater of extremes, a place where planets could be almost star-like, where gravity could forge metals from gases, where heat could rise from the depths long after a world's birth. And if this was the reality of the giants we could see, what of the countless others circling distant stars? The revelations of the 20th century were unsettling, but they were only the beginning. The deeper the gaze into the giants, the more the mystery grew. For centuries, the gas giants were seen only through the distant eye of a telescope, their clouds a curtain that kept their secrets hidden. But in the late 20th century, humanity did something extraordinary. It sent emissaries across the gulf of space, not to orbit the sun, not to remain near Earth, but to cross the entire solar system and peer at these giants up close. The first of these travelers were Pioneer 10 and 11, launched in the early 1970s, twin scouts on a one-way journey. When Pioneer 10 crossed the orbit of Mars, it became the first machine to ever enter the realm of the outer planets. Its cameras turned toward Jupiter, revealing a world far more dramatic than Earth-bound telescopes had suggested. Great swirls of color, bands of brown, gold, and cream, interlocked and tangled like brushstrokes on a living canvas. The Great Red Spot, a storm so vast it could swallow Earth whole, loomed as an ancient eye staring back through time. But Pioneer was only the beginning. In 1977, NASA launched two spacecraft that would become legends, Voyager 1 and Voyager 2. Each was a time capsule, carrying the golden record with messages from Earth. Greetings, music, and the sounds of oceans and thunder, just in case something or someone ever found them in the dark. Their true mission, though, was to explore the giants. Voyager 1 reached Jupiter in 1979 and gave humanity its first close-up look at a gas giant. It saw lightning in the clouds, discovered that the Great Red Spot was not a static scar, but a spinning, turbulent vortex, and revealed Jupiter's rings, faint, gossamer halos invisible from Earth. It also turned its cameras toward the moons, and there, another revelation awaited. Io, a tiny volcanic world, was erupting. Its surface was dotted with volcanoes blasting plumes hundreds of kilometers high. Europa gleamed as an ice world, its cracked surface hinting at an ocean locked beneath the crust. Ganymede, the largest moon in the solar system, showed a surface as complex as a planet's, and Callisto appeared ancient and battered, as if holding the scars of the early solar system. When Voyager 1 and 2 moved on to Saturn, they found a world of impossible beauty. The rings, seen up close, were not solid but made of countless icy particles, orbiting like a delicate cosmic ballet. Within them, shepherd moons carved paths, shaping gaps and waves as though writing music on an invisible staff. Voyager discovered a haze-covered moon, Titan, with a thick atmosphere, a world that seemed to mirror early Earth, though much colder and stranger. Voyager 2 continued alone to Uranus in 1986. The only spacecraft ever to visit the tilted ice giant, Uranus rolled through space on its side, its pale blue atmosphere featureless and calm, yet hiding winds of hundreds of kilometers per hour. Voyager found faint rings, dark and narrow, circling the planet, and moons with surfaces scarred by ancient cataclysms. Then, in 1989, Voyager 2 reached Neptune, a distant sapphire glowing at the edge of sunlight. There it found the fastest winds in the solar system, roaring at over 1,500 kilometers per hour, and a dark storm the size of Earth spinning in its atmosphere. Each encounter was a revelation, but also a provocation. For every answer, three new mysteries emerged. What powered these storms in places where sunlight was weak? Why did Uranus and Neptune have such oddly tilted magnetic fields? Why did some of their moons appear geologically active in a region where the sun's warmth was negligible? By the late 1990s, a new era of exploration was ready to begin. Not just flybys, but a long-term presence. In 1997, the Cassini spacecraft left Earth on a 7-year journey to Saturn, carrying with it the Huygens probe. When it arrived in 2004, it slipped into orbit and began a mission that would last more than a decade, becoming humanity's permanent outpost in the Saturnian system. Cassini sent back images so detailed that the rings themselves became worlds. It watched as storms formed at Saturn's poles, including a massive hexagon-shaped vortex, a 6-sided hurricane spanning 30,000 kilometers across, a structure unlike anything seen elsewhere in the solar system. It dove through the gaps between the rings, mapping their intricate structures and watching them ripple with the gravitational pull of nearby moons. The Huygens probe detached and descended through the atmosphere of Titan, parachuting down to its frozen surface. It saw rivers and lakes of methane and ethane, carved channels, and a landscape eerily similar to Earth's, yet sculpted from entirely different materials. Cassini later discovered geysers erupting from Enceladus, a small icy moon, spraying water vapor and organic molecules into space. Beneath its surface, an ocean of liquid water was revealed, a potential cradle for life far from the warmth of the sun. Even as Cassini's mission came to a dramatic end, plunging into Saturn's atmosphere in 2017 to avoid contaminating its moons, another spacecraft was rewriting the story of Jupiter. The Juno mission, arriving at the gas giant in 2016, carried instruments designed to peer deep into its interior. What it found was surprising. Jupiter's core was not small and dense as once thought, but vast and diffuse, a diluted core extending perhaps half the planet's radius. It was as if Jupiter was still mixing itself billions of years after its birth, its heavy elements stirred into its envelope of hydrogen. Juno also mapped Jupiter's magnetic field in exquisite detail, revealing that it was lopsided and chaotic, far more complex than a simple bar magnet. Its microwave instruments saw deep structures in the planet's atmosphere. Cyclones clustered at the poles in geometric patterns, bands and belts extending thousands of kilometers into the depths. Jupiter was not just a planet, but a restless engine, still reshaping itself. These missions transformed the gas giants from distant orbs into complex, dynamic worlds. Each spacecraft stripped away a layer of ignorance but revealed deeper enigmas beneath. They showed that the giants are not static relics of the solar system's birth, but living worlds still evolving, still interacting with their moons, still radiating energy from within. They also hinted at something greater, that the gas giants may have been architects of the solar system itself, shaping the orbits of planets, scattering asteroids, perhaps even determining whether Earth could become habitable. The deeper the investigations went, the more humbling the picture became. These planets, once reduced to dots of light, had grown into colossi that dominate the architecture of the solar system. Their gravity governs the paths of comets and asteroids. Their magnetic fields sculpt space itself, and their hidden oceans may harbor life. But for all that has been learned, much remains obscured. The probes have only skimmed the upper layers. No instrument has yet descended into Jupiter's or Saturn's core. No camera has seen the bottom of their clouds. What lies deeper is still conjecture. Metallic hydrogen oceans, dissolving cores, heat left over from the dawn of time. The story of the gas giants is not yet complete. It is a puzzle that grows more intricate with every piece we add, a mystery that deepens even as we illuminate it. For every revelation brought back by Pioneer, Voyager, Cassini, and Juno, there is a greater silence beneath the clouds, waiting to be broken. The more humanity looked at the gas giants, the stranger they became. The first close-up images from space had already revealed that Jupiter was not a placid world, but a place of fury, where storms raged large enough to engulf Earth. But the longer the probes and telescopes watched, the more unsettling the picture grew. On Jupiter, the Great Red Spot turns eternally, a storm older than any human nation, perhaps older than modern civilization itself. It is not a hurricane in the ordinary sense, not a weather pattern that appears and fades. It is an engine of the planet's atmosphere, spinning with winds over 400 kilometers per hour, surviving century after century as though sustained by some hidden energy. Even stranger, Juno's measurements have revealed that the red spot extends deep into the atmosphere, plunging hundreds of kilometers below the cloud tops, as though the storm is a vast pillar of rotating air anchored within Jupiter's depths. Surrounding it, a menagerie of smaller cyclones forms, merges, and dissipates in an endless dance. At the poles, Juno has seen vast polygonal patterns of storms, 8 cyclones arranged in a perfect circle in the north, 5 in the south. Structures so geometrically precise that they seem almost designed. Saturn, too, hides a mystery that grows more extraordinary the closer it is observed. At its north pole spins the famous hexagon, a 6-sided jet stream nearly 30,000 kilometers across, locked in place as though carved into the atmosphere itself. For decades it has persisted, turning slowly, holding its perfect geometric shape while storms rage around it. Fluid dynamicists have tried to replicate it in laboratories, and some have succeeded under controlled conditions. But the sheer scale of Saturn's version defies comprehension. It is a natural polygon large enough to contain 4 Earths, an atmospheric riddle that refuses to dissipate. Then there are the ice giants, Uranus and Neptune, which seem even more alien. Uranus, with its 98-degree tilt, spins on its side as if knocked over in some cosmic accident. Its magnetic field is not aligned with its rotation, but tilted wildly, offset from the planet's center, as though generated not deep in the core, but somewhere closer to the surface. Neptune, though far from the sun where light is weak and heat is scarce, harbors the most violent winds in the solar system, reaching speeds of 2,000 kilometers per hour. These supersonic gales roar through the thin atmosphere of a planet, receiving only a fraction of the sunlight that warms Earth. These storms and winds defy ordinary intuition. With so little solar energy available, where does their power come from? The answer seems to lie within the planets themselves. Jupiter and Saturn glow with internal heat, radiating more energy than they receive from the Sun. Their storms may be driven not from above, but from below, by heat leaking from their vast, still warm interiors. Uranus is a strange exception, emitting almost no excess heat at all, while Neptune releases a surprising amount. These hidden energy budgets are not fully understood. They hint that the giants are not in equilibrium, but are still evolving, still settling from their birth billions of years ago. But perhaps the greatest escalation of mystery comes not from their weather, but from their origin. For decades, scientists believed the planets formed near their present locations. Jupiter would have grown first, pulling in gas from the solar nebula, followed by Saturn, and then the ice giants. Yet computer models have struggled to reproduce the exact arrangement of today's solar system under this assumption. New theories suggest something far more dramatic, that the giants may have migrated. According to the Grand Tack hypothesis, Jupiter may have formed farther from the Sun and then migrated inward, like a ship tacking through a stellar wind. It could have plowed through the early disk of dust and rock, scattering planetesimals, truncating the inner disk, and shaping the conditions that allowed Earth and its neighbors to form as small, rocky worlds. Then, as Saturn grew and was caught in resonance with Jupiter, the two giants may have reversed course, migrating outward together in a gravitational dance that sculpted the solar system into its current shape. The Nice model, named after the city in France where it was developed, goes further. It proposes that after the gas giants formed, they were once arranged in a much more compact configuration. As they interacted with a disk of icy debris beyond them, their orbits shifted chaotically. Uranus and Neptune may have been flung outward to their current distant positions, stirring up the Kuiper belt and triggering a late heavy bombardment of the inner planets. If this picture is correct, then the early solar system was not a calm nursery, but a place of violent rearrangement, where worlds were hurled across space and countless smaller bodies were ejected entirely. This violent past has profound implications for Earth. Without Jupiter's gravity sweeping up or ejecting countless comets and asteroids, the inner solar system might have remained a shooting gallery, too unstable for life to flourish. Some simulations suggest that Jupiter shields Earth from catastrophic impacts, acting as a gravitational gatekeeper. Others propose that Jupiter also helped deliver water to Earth by scattering icy bodies inward in the distant past. In either case, the gas giants may have determined whether Earth could ever become a cradle for life. The mysteries multiply because every revelation deepens the sense that these planets are not merely spectators in the story of the solar system. They are protagonists. They control the architecture of planetary orbits. They stir the belts of asteroids. They dictate the rhythm of impacts. And they hold clues to the conditions that allowed Earth to be what it is. The more their atmospheres are studied, the more their hidden interiors are modeled, the more they seem like unfinished worlds, still evolving, still active, still reshaping space around them. Seen this way, the gas giants are not just strange worlds on the edge of human imagination. They are architects, guardians, and sometimes destroyers. They are the reason Earth's orbit is stable enough for life to endure. They may also be the reason mass extinctions have periodically occurred, when their gravitational influence sends comets inward from the Oort cloud, sparking impacts that reset the course of life. The giants are both protectors and harbingers of chaos, capable of sculpting entire epochs with a single gravitational nudge. To study them is to confront the deep interconnectedness of the solar system. A recognition that Earth's story cannot be told in isolation. Every storm that brews on Jupiter, every subtle shift in Saturn's orbit, every dark gale sweeping Neptune's horizon is part of a larger symphony of motion, a pattern stretching back 4.5 billion years. And yet, even with this growing understanding, the greatest questions remain unanswered. Why does Jupiter's core appear diluted, as though mixed with lighter elements? Why does Uranus radiate so little heat, while Neptune radiates so much? Why do some of Saturn's rings look young, perhaps only 100 million years old, while others may be ancient? Each answer seems to open a door into a deeper, stranger chamber of mystery. The gas giants are no longer simply destinations for flybys. They have become puzzles that challenge the very models of planetary science. Their storms refuse to fade. Their magnetic fields defy simple explanation, and their histories seem written in a language only slowly being deciphered. They are the solar system's most enduring enigmas. And the deeper they are studied, the more they seem to hold the keys to our own existence. In the silence of deep time, the solar system was once a restless ocean of dust and fire. Planetesimals collided, merged, and shattered in a violent ballet, and out of that chaos emerged the four giants: Jupiter, Saturn, Uranus, and Neptune. But their story was never static. Their orbits, once thought eternal, may have shifted like dancers changing their steps, rewriting the script of the early solar system in ways still being uncovered. Modern planetary science has begun to suspect that Jupiter, the largest and most influential of them all, did not always dwell where it does today. According to the Grand Tack hypothesis, it may have formed far beyond its current orbit, a newborn colossus gathering mass from the solar nebula. As it grew, it began to drift inward, pulled toward the Sun by gravitational interactions with the surrounding gas. For a time, Jupiter may have reached as close to the Sun as Mars is today, its immense gravity disrupting the material that would have formed larger worlds near the star. Some theorists believe this is why our solar system lacks a super-Earth, those giant rocky planets so common in other systems. Jupiter may have been the gatekeeper that prevented one from forming. But the story does not end there. As Saturn coalesced behind it, their gravitational resonance locked them together, reversing their migration and driving them outward. Together, the two giants carved through the protoplanetary disk, scattering debris, reshaping the asteroid belt, and leaving behind a solar system where the inner worlds could remain small, rocky, and stable. Without this migration, Earth might not exist as it does. Its orbit could have been destabilized, its formation interrupted, its surface sterilized by unending bombardment. The giants, through their migration, may have set the stage for life itself. Beneath the clouds, the story grows stranger still. These planets are not solid worlds like Earth. They are titanic spheres of gas and liquid, their atmospheres blending seamlessly into deeper layers under crushing pressure. As one descends into Jupiter, hydrogen is squeezed into a state unlike anything found naturally on Earth. It becomes metallic, not in the sense of shining like steel, but in the sense of conducting electricity freely, forming vast oceans of metallic hydrogen surrounding the core. It is here that Jupiter's mighty magnetic field is born, a magnetic field so immense that it stretches millions of kilometers into space, dwarfing the Sun's own influence in certain regions. Saturn is thought to harbor a similar metallic hydrogen layer, though its magnetic field is strangely symmetrical, a puzzle that defies the usual dynamo theory and suggests something exotic is happening deep within. Uranus and Neptune, on the other hand, may contain mantles of superionic water, a bizarre state of matter where water's oxygen atoms form a crystalline lattice while its hydrogen ions flow freely like a liquid metal. If this is true, the oceans of Uranus and Neptune are nothing like those of Earth, but more like glowing, conductive slurries under pressures millions of times higher than atmospheric pressure. And even deeper lies the enigma of the cores themselves. Juno's measurements suggest that Jupiter's core is diluted, not a compact ball of rock and ice, but a vast, diffuse region where heavy elements are mixed throughout the interior. This could be the result of a colossal impact in the planet's youth. Perhaps a collision with a planet 10 times the mass of Earth, shattering Jupiter's early core and leaving it in a state of eternal mixing. Saturn, too, may have a fuzzy core, one that gradually blends into the surrounding layers instead of forming a sharp boundary. These worlds are not static, frozen objects. They are still evolving, still convecting, still alive in a planetary sense. What might exist far below the clouds remains unknown. Some scientists speculate that exotic forms of matter could form under such extreme conditions. Phases of hydrogen, helium, and water that cannot be replicated in laboratories, superconducting layers, degenerate metallic phases, perhaps even forms of matter that behave in ways not yet predicted. Each probe that flies past only touches the outermost skin of these worlds, leaving their deep interiors a realm of speculation. And then comes the most provocative idea of all, that these planets are failed stars. In many ways, Jupiter is like a star that never quite ignited. If it had been about 80 times more massive, the pressures at its core would have been sufficient to trigger nuclear fusion, making it a red dwarf star. Our solar system would then have been a binary system, with two suns, one blazing and one faint. In this sense, Jupiter sits at the boundary between planet and star, a reminder that the line separating these categories is thin and blurred. The thought is humbling. A little more mass, a little more gas, and the night sky would never have known true darkness. Earth might have been bathed in perpetual twilight, its seasons, tides, and climates entirely different. Life might never have arisen, or perhaps might have arisen in ways we cannot imagine, beneath two suns. Even without nuclear fire, the gas giants shaped the solar system as though they were secondary stars. Their gravitational influence extends across billions of kilometers, controlling the fates of comets, shepherding asteroids, and stabilizing planetary orbits. In simulations of planetary systems without giants, inner planets are often flung into their stars or collide catastrophically. It is possible that the very existence of a calm, habitable Earth depends on these remote titans. Speculation stretches even further. Some astronomers have wondered whether Jupiter and Saturn's migrations may have delivered the building blocks of life, icy planetesimals carrying water and organic molecules, into the inner solar system. If so, the gas giants are not just protectors of life but midwives, seeding a once barren world with the chemistry that would eventually give rise to oceans and biology. And yet, for all that is known, the giants remain enigmatic. Beneath their clouds, pressures rise to millions of atmospheres. Temperatures soar to tens of thousands of degrees, and matter is transformed into states no human has ever seen. No probe has yet descended to those depths. None could survive long enough to tell the tale. The Galileo probe plunged into Jupiter in 1995, falling for just under an hour before the crushing pressure destroyed it. It sampled only the shallowest layers, barely scratching the surface of the mystery. This leaves humanity with a paradox. The gas giants are the largest objects in the solar system after the Sun, yet they are also among the least explored. Their surfaces, if the word can even be used, are inaccessible. Their cores are hidden behind walls of cloud and storms that have raged for centuries. Their formation history is written in gravitational scars, scattered across billions of kilometers of space, only partially deciphered. They stand as both guardians and riddles, as architects and enigmas. To study them is to confront questions that reach beyond planetary science into philosophy. Are worlds like these common in the galaxy, shaping the habitability of planets everywhere? Do they act as cosmic filters, determining which systems can harbor life? Are we here, on a small blue world circling a quiet star, because 4 giant planets once danced through the early solar system, sculpting the stage for biology to emerge? The answers lie hidden in the depths, waiting for the next generation of explorers. Future missions may send probes to sample their atmospheres directly, to map their interiors with unprecedented precision, to dive deeper than ever before. Perhaps one day, landers will float on the seas of Titan or plunge into the metallic hydrogen oceans of Jupiter. Until then, the giants remain what they have always been: majestic, mysterious, and essential. The silent shapers of the solar system's destiny. The quest to understand the gas giants did not end with Voyager's final images fading into the stars. It did not end when Galileo plunged into Jupiter's clouds, or when Cassini gave its last signal as it burned in Saturn's atmosphere. In truth, it never ends. Each mission has been a prelude to the next, each discovery an invitation to go deeper. Humanity has only begun to scratch the surface of these colossal worlds, and the instruments now watching them are sharper, faster, and more relentless than ever. Orbiting Jupiter today is Juno, a spacecraft purpose-built to see what no eye has seen before. Unlike the swift flybys of Voyager, Juno dives again and again into Jupiter's gravity well, looping over its poles in long, sweeping orbits. Its instruments peer beneath the planet's cloud tops, mapping its gravity field with exquisite precision, teasing out the secrets of its interior. With each pass, Juno measures how Jupiter's mass is distributed, how its core might still be mixing after billions of years, how deep its famed storms penetrate into its depths. Its cameras capture cyclones at the poles, vast spirals of cloud arranged in eerie geometric patterns, like petals on a planetary flower. It sees lightning flashing within ammonia storms, jets that flow thousands of kilometers deep, and an atmosphere so dynamic it seems to breathe. But Juno is not alone. Beyond Earth, entire fleets of machines are now being prepared to continue the investigation. The European Space Agency has launched JUICE, the Jupiter Icy Moons Explorer, a mission destined to enter orbit around Ganymede, the largest moon in the solar system. JUICE will study the ice-covered worlds of Jupiter's system, probing their subsurface oceans, searching for the conditions that might make life possible beneath their frozen crusts. For the first time, humanity will orbit a moon beyond Earth's own, turning these distant satellites into laboratories for understanding the interplay between giant planets and the worlds that circle them. Soon after, NASA's Europa Clipper will arrive, making dozens of close flybys of Europa. Its instruments will scan for plumes of water erupting from cracks in the moon's icy shell, measure its magnetic field to confirm the presence of a salty ocean, and search for chemical signatures that might hint at biological activity. Though focused on a moon, this mission is also a mission about Jupiter, for Europa's ocean is kept warm by the giant planet's tidal pull. Every discovery about that ocean is also a discovery about the gravitational power of the gas giant itself. The giants beyond remain waiting. Uranus and Neptune have not been visited by a spacecraft since Voyager 2's brief flybys in the 1980s. Yet they are now targets for a new generation of explorers. Concepts are being drawn for orbiters and atmospheric probes that could linger in their icy skies, measuring their magnetic fields, tasting their atmospheres, and finally answering why their internal structures are so different from their larger siblings. Saturn too may one day host a probe that will plunge through its upper atmosphere, transmitting data until the pressure and heat silence it forever, much as Galileo once did at Jupiter. And while spacecraft approach them from the void, other eyes watch from far away. Telescopes in orbit and on Earth are now tuned to study gas giants across the galaxy. The James Webb Space Telescope, with its gold mirrors and infrared gaze, has already begun to measure the spectra of exoplanetary giants, teasing apart their atmospheric chemistry, their heat signatures, even the hints of weather on worlds hundreds of light years away. Each measurement provides a cosmic mirror, a chance to compare Jupiter and Saturn with countless other versions scattered through the Milky Way. Some are so massive, they blur the line between planet and brown dwarf. Some orbit so close to their stars that their atmospheres are superheated and stripped away by stellar winds. These alien giants become test cases, revealing how our own planets might look under different circumstances, and how rare or common a system like ours may be. Back on Earth, scientists are recreating pieces of these worlds in the laboratory. In facilities that use diamond anvil cells, hydrogen is squeezed to pressures millions of times higher than Earth's atmosphere, briefly forming metallic states that may exist deep inside Jupiter. Experiments in shock physics create conditions like those inside Saturn's core, revealing how helium separates from hydrogen and rains downward, releasing heat and explaining the planet's mysterious luminosity. Magnetic field models, running on supercomputers, simulate how vast dynamos churn inside these giants, producing the invisible structures that trap radiation, sculpt auroras, and shape the space around them. Every simulation, every measurement, every new image brings a fragment of understanding, but also new puzzles. Juno's maps of Jupiter's gravity field showed that the planet's core is diffuse, perhaps stirred by an ancient collision. But it left unanswered how deep the Great Red Spot extends, how its magnetic field shifts over time, and what drives its mysterious X-ray auroras. JWST's glimpses of exoplanetary giants show clouds made of silicates and iron, but raise questions about how such worlds form and migrate. Laboratory experiments create metallic hydrogen only for an instant, leaving its true properties still uncertain. The work continues, pushing at the boundaries of both technology and theory. This is the nature of exploration. Each question answered opens the door to 3 more. Every spacecraft that flies past a gas giant leaves a wake of curiosity that must be followed. The future will demand more daring missions, perhaps atmospheric balloons that drift for weeks in the upper layers of Jupiter or Saturn, or cryobots that melt through Europa's crust to swim in its ocean, all tethered to the invisible will of these massive worlds. What emerges from these efforts is not just science, but perspective. Humanity is learning piece by piece that the gas giants are not remote curiosities, but central to the story of why Earth is here, why it is habitable, and why life had a chance to flourish. Their storms, their gravity, their migrations are threads in the tapestry of our own existence. The tools are growing sharper, the questions are growing deeper, and the giants remain, waiting under their veils of cloud, keeping their deepest secrets for the next generation of explorers willing to cross the void. In the stillness of space, the giants turn. They turn as they have for billions of years, their vast storms spinning silently, their magnetic fields sweeping invisible arcs through the dark. They are the keepers of the outer solar system, guardians that have shaped everything we know, and yet they remain untamed, wild, and mysterious. Their presence is not an accident of nature, but a force that sculpted the destiny of every smaller world that circles the sun. Without Jupiter's gravity, comets would have rained endlessly upon the inner planets, sterilizing their surfaces before life could gain a foothold. Saturn's pull, too, helped sweep the solar system clean, guiding stray debris into safer orbits, breaking the chain of destruction that once threatened every young world. In a real sense, these planets stand watch over Earth. They are its silent protectors, intercepting danger, capturing comets, deflecting asteroids. They are the shield that allowed time to pass quietly enough for oceans to form, for continents to rise, for biology to awaken. And yet, they are also destroyers. Their gravitational reach can hurl worlds into chaos, eject planets entirely from the solar system, or send icy bodies crashing toward the inner worlds. They are architects of both creation and ruin, their influence capable of bringing order or chaos depending on the delicate dance of orbital resonance. They are a reminder that nature does not choose sides. It only moves according to its laws, indifferent to the small and fragile. Their storms are echoes of the early solar system, when everything was storm, when planets were still colliding, when moons were being born, when the very dust of the nebula was shaping itself into worlds. The Great Red Spot is a survivor of that ancient violence, a vortex that has outlived empires, civilizations, and perhaps even species. To watch it spin is to look backward through time, to witness a fragment of the solar system's primal fury that never calmed. Saturn's hexagon is another of these symbols, a perfect, unbroken shape turning endlessly at the pole of a world that has seen everything since the dawn of the sun. To gaze upon these giants is to confront scale, not merely physical scale, though their sizes dwarf the imagination, but temporal scale. Their storms will likely still be there long after humanity is gone. Their magnetic fields will keep turning, their heat will keep leaking into space, their moons will keep circling, tides pulling at their surfaces, driving internal oceans. Even as the sun swells into a red giant billions of years from now, Jupiter and Saturn may remain, slowly cooling in the deepening twilight, witnesses to the final chapters of the solar system's story. And still, questions remain. What exactly lies at Jupiter's heart? Is there a solid remnant of the planet that once was? Or has the core dissolved into a great storm of heavy elements that churn forever? How deep do its belts and zones truly go? Are they just surface features? Or do they extend thousands of kilometers into the abyss? What other forms of matter hide at pressures too great to replicate on Earth? Are there phases of hydrogen and helium unknown to physics, waiting only for us to imagine them? These questions reach beyond our own system. Across the galaxy, there are trillions of giant planets circling other stars. Some far larger than Jupiter, some as small as Neptune but as hot as ovens. Some locked so close to their stars that a year lasts mere hours. Are they too guardians of their systems, shaping which planets can hold life and which are doomed? Or are we in a rare cosmic arrangement, fortunate enough to have giants at just the right distance to protect a habitable world? If the giants had formed differently, if they had migrated too far inward or outward, would Earth exist at all? Would anything exist at all? In some profound sense, these planets may be part of our origin story. They are not just neighbors, they are participants in the very possibility of life. Their gravity sculpted the solar system. Their migrations created safe havens. Their presence shielded Earth long enough for its chemistry to spark into biology. They are both distant and deeply intimate, strangers and ancestors at the same time. And so humanity looks up at them, through telescopes, through spacecraft cameras, through dreams. Jupiter still turns under the stars, its great red spot slowly rotating, whispering a secret in a language of storms. Saturn still glows in the sunlight, its rings casting delicate shadows on its cloud tops. Uranus and Neptune still drift at the edge of the sun's influence, their blue atmospheres hiding enigmas that have waited 4 billion years to be uncovered. Somewhere, beyond even them, other stars turn, Other systems dance. Other giants shape the fates of other worlds. Perhaps life blooms under their protection as well. Life that may one day look back at its own sky and wonder about its guardians. The story of the gas giants is not just the story of distant planets. It is the story of why we are here at all. To study them is to study the conditions for existence itself. And though humanity has crossed the gulf with machines, though it has mapped their magnetospheres and traced their storms, the giants still hold their deepest truths in silence. They will keep turning. They will keep raging, and we will keep listening. Because somewhere, in the endless winds of Jupiter, in the crystalline hexagon of Saturn, in the tilted fields of Uranus, in the howling storms of Neptune, there are answers. Answers to where we came from, why we are here, and what kind of universe we inhabit. Under starlight, they wait, enormous, eternal, indifferent, and yet in their vastness, strangely familiar. Their storms are the solar system's heartbeat. Their gravity is the memory of its birth. Their silence is not absence but invitation. And so the final image lingers. Jupiter, turning slowly, its bands glowing in the faint light of the distant sun, the great red spot still watching, still breathing, still enduring, as if whispering that the greatest mysteries are never solved, only approached, one question at a time.